In this video, I'd like to provide an introduction for teachers and parents to the study of the classical quadrivium. Normally, when we talk about classical education, focus turns to Latin and Greek studies, literature, and things like that, all of which belong to the language arts. What's often neglected in classical studies is the ancient mathematical arts that are known together as the quadrivium. If we look at modern schools that claim to be classical, we'll often find Latin classes or maybe a Greek class. We'll find great books classes. But when we look at their math program, we often find nothing but modern math courses. We find kids in K through 6 working in arithmetic and then moving into algebra, some geometry, modern geometry in high school, and then algebra 2, and then maybe some trigonometry and calculus if they're really ambitious. But the classical mathematical arts are just neglected. And in this video, I'd like to talk about what they are, where they come from, and how they're studied, and how we study them in the Classical Liberal Arts Academy. Now, the assumption behind this division of studies is that we're interested in philosophical learning. We're interested in the pursuit of wisdom. So that's an assumption. This isn't about college preparation. This isn't about career preparation. All of that would be classified under the mechanical or illiberal arts. The classical liberal arts were for people who were concerned with the study of wisdom and philosophy, set apart from, temporal, material pursuits in this life. It doesn't mean that they were wealthy people. It means that they were studying to understand and know things that didn't have some practical, mechanical, or material end as the motivation for those studies. We're studying these things for the sake of wisdom and philosophy, and we'll explain a little more about that as we go along. So this is the real reason why the quadrivium is not in modern schools, and it includes schools that claim to be classical, is because those schools really are not ordered to the pursuit of wisdom. And so these studies have no place in the curriculum of those schools. If we have a school that pursues the true end of human learning, which is wisdom, we'll find that the quadrivium has a central place in the curriculum and must be given our full attention. Now, where does the quadrivium come from? All right? If we go back to Aristotle, as I explained in the introductory lesson that I gave on classical reasoning, which you might want to check out now before continuing in this video, I explained what the categories were. I explained that Aristotle, speaking within the art of classical reasoning, addressed the 10 classes or genera of predicables, things that may be predicated of subjects. And he explained them in his work called The Categories. I explained also that this word categories is simply a Greek word that means predicates. And so it's the 10 classes or genera of predicable things. That's what the categories are. The first of these was substance. That was the first of the 10 categories. The second of the 10 categories is quantity. Okay, now, once Aristotle identifies these 10 categories of predicables, these need to be investigated as separate philosophical arts and or sciences. All right, so once the 10 categories are identified, now we need to use the method of investigation, which is demonstrative reasoning, as we discussed in that other video, to investigate these different categories and understand how they divide, whether they divide into species down to the individuals contained under these 10 most general genera, as we learn in the categories, so that we can have a philosophical knowledge and mastery of each of these different categories of study. Okay? So this starts with Aristotle's philosophy of the categories, which divides all possible predicables. The first is substance, the second is quantity. Now, as we begin a philosophical investigation of quantity to understand what it is, we find that it divides into two species. So there are two species of quantity, and those species are multitude and magnitude. The definition of quantity, before we go any further, is a quantity is anything that can be increased or diminished in number or in value. Okay? Anything that can be increased or diminished is a quantity. But what we find is that there are two different kinds of quantities. One kind of quantity is a collection of separate objects. A collection of separate objects is a multitude. Another type of quantity is a figure that can increase or diminish in size, and such objects are magnitudes. So the two classes of quantity are multitude and magnitude. This is the result of philosophical investigation. We find that the category known as quantity divides into two species, multitude and magnitude. Okay? That's our first step. Now, as we continue this investigation, we look into multitude and we find that multitude itself divides into two species, and these are absolute multitudes and relative multitudes. So there are quantities that are made up of collections of separated objects. Some of these are absolute and other of these are relative. Absolute means they refer themselves to unity. So for example, the number 7 is a quantity that is a collection of what the Greeks would call monads or units. So 7 units make up the quantity, the absolute multitude 7. Absolute multitude, we can understand this as a simple number. And we study absolute multitude through the art of arithmetic. Arithmetic is the study of absolute multitude. Okay? Relative multitudes are multitudes that are not referred to unity, but are referred to some other quantity. And where we find relative multitudes is in the study of music. So music, for example, any relative multitude like 1/2, the measures of music, the time measures of music, the relationships between the lengths of strings in musical instruments, all of those relative multitudes, which we could easily refer to as ratios, they're studied under this second species of multitude, which is relative multitude. And as I said, the art or the study of relative multitude is in the classical quadrivium, the study of music. So we have arithmetic and music, two arts that make up the quadrivium. And what they actually are the studies of two different species of multitude. Okay? So these are not just random subjects that are, chosen because we think that they're enjoyable or helpful. They're actually two necessary arts that are related to two actual divisions of the two species of quantity within philosophy. Okay? So that's how we come to our first two of the 4 mathematical arts. If we go back up to quantity, we find the other division of quantity is magnitude. And as I said, magnitude refers to a quantity that can increase or diminish in size, yet is itself one body. Magnitudes can be divided into two different species. And the difference that separates them or distinguishes them is that some are at rest and some are in motion. So magnitudes divide into magnitudes at rest and magnitudes in motion. The study of magnitudes at rest is geometry. And the word is derived from the measurement of the earth, because within the Ptolemaic system, within Ptolemaic astronomy, it was understood that the earth was at rest and the heavens were in motion. So geometry was the study of physical bodies or magnitudes at rest. Astronomy was the study of physical bodies or magnitudes in motion. All right, so again, within the Ptolemaic astronomy, the heavenly or celestial objects that we see overhead were considered to be in motion, and the study of them was named astronomy. So we have these four mathematical arts: arithmetic, music, geometry, and astronomy. And where these four arts come from are the four divisions of quantity: 2 under multitude and 2 under magnitude. So as we investigate the second of the 10 categories, which is quantity, we find there are 2 necessary divisions. And then as we investigate that first division, we find there are 2 necessary divisions. And then there is an art or science that is focused on the investigation of each of these 4 divisions of quantity. Okay, so the 4 mathematical arts are referred to as the Quadrivium because it's a collection of 4 ways or 4 methods of investigating the subject of quantity. All right, so when we look at the classical curriculum, we find that there are 4 mathematical arts. And again, these are not just random. We don't just pick these because we think that they'd be interesting studies. For the study of quantity, which is one of the 10 categories within Aristotle's philosophical system, for the study of quantity, we must study arithmetic, music, geometry, and astronomy. We must study these 4 divisions in order to study quantity. Okay, so these 4 studies are necessary for the study of mathematicals. Now, when we get into the study of arithmetic, or even before that, we have to ask the question, of these 4 arts, is there one that comes first? Is there any order in these 4 arts? And it can be proven, as Boethius provides us with arguments in his work on arithmetic, it can be proven that arithmetic comes first. And the reason why is because the doctrines of arithmetic are required for us to speak about music or geometry or astronomy. You cannot speak of any of these 3 mathematical arts unless you've already established the terms and principles of arithmetic. So arithmetic comes first in the classical curriculum. Arithmetic is the study of absolute multitude, which we can easily understand as numbers. Once we understand the doctrine of numbers, then we can use that to talk about relative multitudes. Music follows arithmetic. So let's put a 1 under arithmetic and a 2 under music because music comes after arithmetic. However, music is not necessary for the study of geometry or astronomy. And so we can also go from arithmetic straight into geometry. We need to know the principles of arithmetic for the study of geometry because in order to speak of the figures in geometry, we already need to have number established. So arithmetic is a clear number 1, where the classical and mathematical arts begin. Once we're through arithmetic, though, we can continue into music and into geometry. In fact, because geometry begins with memory work, we can begin arithmetic and geometry together. And then lastly, astronomy. I'll put a 4 under astronomy, because astronomy already assumes the knowledge of geometry. Astronomy is held for last of the 4 classical mathematical arts. So those 4 arts in this order make up the Quadrivium, which is the study of the 4 classical mathematical arts. And again, I want to emphasize the fact that these 4 studies are necessary if we're going to understand the philosophical concept of quantity. So these aren't optional. We don't pick and choose which ones we like and don't like. we must study these four mathematical arts if we're to understand quantity in full. Now, the next question is, how do we study these four arts? Well, as with most of the arts, it's very simple because there is a master who composed the master textbook, and studying that textbook is equivalent to studying each of these four arts. For arithmetic, the best source that we have as Catholics to go to is Boethius. I'm not sure if I can fit this in the screen down here, but I'll just write it in here. So Boethius, a medieval Catholic who composed the art of arithmetic. Now, obviously, as a medieval Catholic, arithmetic is an ancient science established in ancient Egypt, studied through ancient and classical Greece, in ancient even Babylon and Sumeria. So the study of arithmetic is ancient, but we have a summary and a translation of what was known of the art of arithmetic in the Middle Ages by Boethius around 600 AD. So Boethius's De Arithmetica is the text that's studied by Catholics on the art of arithmetic. For music, it's also Boethius. He also published a text called De Musica. So De Arithmetica and De Musica are the two texts we use for the study of multitude, and the source of both of them is Boethius. When we get into geometry, everybody's familiar with Euclid. And it's Euclid's Elements, which is the master text for the study of classical geometry. Now, people in modern schools will refer to Euclidean geometry as a kind of geometry, even in modern schools. And we have to ask if Euclidean geometry is just one kind of geometry, well, what other kind of geometry is there? And what we find is in modern mathematics, when we get into philosophers like René Descartes, for example, we enter into other studies where two studies are sort of combined. Algebra and arithmetic and geometry are combined to form what becomes known as a sort of algebraic or analytical geometry. And that's what's focused on in many modern schools, but Euclidean geometry is the true classical geometry. Okay, so Euclidean geometry is studied in the Elements of Euclid, which we study in the Classical Liberal Arts Academy. Lastly, astronomy. Astronomy is a controversial one because, as I said, the assumptions present in this system are Ptolemaic. And what that means is the ancient astronomer Claudius Ptolemy, who taught that the Earth was at rest at the center of the universe, and the celestial objects, the heavenly bodies, moved around the Earth. That's a Ptolemaic model of the universe. And we all know as Catholics of the controversies in the 15 and 1600s as that system was challenged and abandoned by modern astronomers. So this mathematical science assumes the Ptolemaic model of the universe. And therefore the source text on classical astronomy would be the astronomical works of Claudius Ptolemy. And this makes some people feel uncomfortable. Is it okay for us to say that the Earth is at rest at the center of the universe and that the heavens revolve around the Earth? Or has it been proven, what about Galileo and Copernicus? Hasn't it been proven that the Earth is actually in motion and the heavenly objects, or at least some of them, are at rest and some in motion? Well, this was a controversy until the time of Einstein, and there's a book called The Evolution of Physics that was written by Einstein, and he confirms that the question of Ptolemaic versus Copernican worldviews, or cosmology, is really just a matter of reference point. Okay, so if we're going to start with the Earth and we're going to assume the Earth to be at rest, it's perfectly true to say that in reference to the Earth, assuming the Earth is at rest, the heavens are in motion. And that's what Ptolemy did. He took the earth at rest as an assumption and then reasoned from there and judged by observation and by apparent motion and said that the heavenly objects are in motion and the earth is at rest. All that Galileo and Copernicus and them did was start with a different point of reference, call that object fixed and at rest, and then interpreted all motion in relation to that fixed object. Okay, so it's two different frameworks, two different systems of looking at the universe, but really what they are two different points of reference and two different ways of looking at the universe. It's not true to say that the Ptolemaic model of the universe was proven to be false by Galileo and Copernicus. That's not true. The argument made by those astronomers is that having a heliocentric model made calculations and studies easier and simpler. And that's what they were actually arguing for, that the heliocentric model was a superior model for the sake of astronomical studies. But within the classical system of philosophy, we stick with the astronomy of Ptolemy, with the earth at rest, as is implied by the word geometry, and an assumption that the heavenly bodies are in fact in motion, and the study of them, astronomy, is one of the four mathematical arts. So the four masters we study to learn the Quadrivium, we study Boethius's work on arithmetic, Boethius's work on music, Euclid's work on geometry, and Ptolemy's writings on astronomy. Those are the classical primary sources for the four mathematical arts that make up the Quadrivium. In the Classical Liberal Arts Academy, we offer all four of these courses. The only challenge that we face in teaching these is that Euclid has been widely translated. You can easily find English translations of Euclid's Elements, but when you get into the other arts, arithmetic, music, and astronomy, we really need to be able to go back to at least Latin and to study the texts in full. We can find translation efforts made for these works, but they're poor quality. And for us to get into these studies, at least at this point, we need to go back to the Latin text of Boethius to study arithmetic and music. And I believe we can find a good English translation of Ptolemy. Actually, a professor at Princeton just published Ptolemy's Almagest in English translation. So there is a modern translation available for Ptolemy's Almagest, it's called, which is his work on astronomy. But still, I think by the time a student in the Classical Liberal Arts Academy was ready to study classical music or classical astronomy, I think he would have sufficient language skill to be able to access those studies in Latin or Greek. So we'll have those courses all available, God helping us in English translations so they're more accessible to more students, but they may end up being reserved for students who have sufficient Latin skill to enter into those subjects in the classical languages. But anyway, what I want parents and teachers to understand is that these four subjects are divisions of the study of quantity, which is one of the 10 categories of Aristotle's rational philosophy. That's where all of this comes from. Now, when we look at our kids' studies and we start to talk about high school math, for example, we have a dilemma that we have to work with. And the right answer to this question, what should our children study? The only right answer is everything. That's the right answer. We just have to deal with the fact that in order to give our children a full Catholic philosophical education, if that's our goal, and to also satisfy temporal, modern requirements, we can't allow it to become a matter of picking and choosing which one we're going to do. We can't, we can't say we're all in on classical philosophy and then irresponsibly neglect modern mathematics. There's no excuse for doing that. It's just lazy. At the same time, we can't say, I don't have time to study classical mathematics because I'm just worried about college admission and so on. So I'm going to study, algebra and sort of a fake modern geometry and get into almost useless studies of trigonometry and calculus that unless you're an engineer or a math professor, there's no practical use for those anyway. So claiming to pursue them because of some practical necessity really isn't even honest. We want to study the classical mathematical arts, and we also need to study the modern mathematical arts. We need to study algebra, we need to study modern geometry, as I said. We need to study some trigonometry and maybe some calculus. In the Classical Liberal Arts Academy, the good thing is that we have a complete system available for both the classical mathematical arts and the modern mathematical arts. The problem is the kids have to put the time and effort into these studies so that they can get all this work done. I just think that there's too much of an influence from this public school idea that we study from 8 to 3, 180 days a year, and then outside of that, there's no study. We have to realize that calendar of studies is completely artificial and isn't any kind of rule. What determines how much we have to study is how much there is to be learned. And if our kids are only going to devote their K to 12 years to this kind of free academic work, and then after that, it's going to be just all business, all practical professional pursuits and studies, then they're never going to learn any of these things. And so we have to make an effort to challenge our kids and help our kids to study more, because there's a lot to be learned, and as Catholics we can't pick or choose. We can't pick math and science or philosophy. We can't pick social studies or theology and philosophy. We have to do both, and if we're going to err on either side, we should be erring on the side of classical Catholic studies. And there are other issues involved. For example, there's the issue of contemplative life, religious vocations. It's not true that every kid has to find some secular vocation that makes money. That's not true. There are other options in life, and we have to leave those options open. When we say, well, no one's interested in religious vocations, how is the education that they're receiving encouraging them or preparing them for religious vocations? They don't even understand the concept of a contemplative life. And so it's sort of a circular argument. We're going to give our kids a secular education that's obsessed with college admission and career opportunities, and then we're going to wonder why they're not interested in religion, and then we're going to use the lack of interest in religion to justify converting the school to more and more secular studies. And you see how it's just sort of this vicious cycle that doesn't produce or foster religious vocations, and even makes it difficult for students who are interested in religious vocations to pursue them, because there's just nothing in place for anyone who would be interested in a religious vocation. So this dilemma is one that we as Catholics have to take on and overcome. We have to study more, we have to put more time into study, we have to put more school days into study, because there's a lot to learn, and we can't neglect these philosophical studies because we're obsessed with practical concerns, which are really just worldly anxieties. And let me just throw this out, okay? In ancient times, in ancient Greece, the study of geometry was so important to the Greeks that Plato, in the Republic, explains that geometry leads students to the contemplation of the eternal. Geometry leads students to the contemplation of the eternal. That sounds like contemplative life. Geometry leads students to the contemplation of the eternal and creates in them the spirit of philosophy. That's the teaching of Plato on the art of geometry. Classical geometry leads us to contemplate the eternal and creates in us the spirit of philosophy. We cannot neglect these studies. We cannot neglect the study of philosophy. And these four ancient mathematical arts are nothing else than a study of one element of true philosophy. So we have dilemmas that we have to deal with. We have to face these things and overcome them. We have to abandon this modern idea of the well-rounded, good at everything American kid who doesn't have time for any advanced studies, doesn't have time for reasoning, doesn't have time for rhetoric, doesn't have time for moral philosophy, doesn't have time for theology or scripture study because he's just so busy. Busy what? Busy what? We have to study classical philosophy, and that begins in these classical mathematical arts. So in the Classical Liberal Arts Academy, I'm not just complaining about modern education. I believe that we have the solution to this. I believe that by restoring the classical mathematical arts and making them accessible to the kids, but also making modern mathematical arts available in efficient courses that don't waste their time, don't drag them into all kinds of distractions and nonsense, but just allow them to get the work done over the course of the entire year. If kids use these courses diligently, the classical mathematics courses and the modern mathematics courses, they can do both in the Classical Liberal Arts Academy. And that's what I'd like to see them attempt to do. They can do it. It's a matter of sitting down and getting the work done over an extended period of time. So I hope that's a helpful introduction to the ancient arts of the Quadrivium. As I said, this is a study of one division of the categories within Aristotle's rational philosophy. If you don't know what I'm talking about, go back and watch the introduction video to classical reasoning, and you'll see where this is explained in Aristotle's works. And as we get going through, I invite you to continue with me as we walk through the Quadrivium together, and also walk through the classical reasoning introduction for parents and teachers, and through the philosophy introduction for parents and teachers. So I'm trying to make these resources available to help, and hopefully we can help our kids to do both, because that's the challenge that Catholics face in the modern world. We have to try to do both. And if we're going to err, we have to err on the side of Catholic philosophy and theology. So I hope that's helpful. God bless your studies.